Hello, this is question 6 from the Specimen B MAT paper. We've got Alice, Bob, Charlie and Diane, and they each make a statement. Only one of them is telling the truth. Which one? Explain your answer. Okay, so one of them telling the truth. Alice is saying that she's telling the truth. Bob is saying that Alice is telling the truth. All right, okay, that's already causing a problem, I think. Charlie's saying that Bob is telling the truth, and then Diane is saying that Charlie is lying. So, well, it looks like the first three of them are all saying the same thing, aren't they? So if Alice was telling the truth, then that would mean that so's Bob and so's Charlie. Well, I think it works for any of them, doesn't it? If Bob's telling the truth, then so's Alice and so's Charlie. And if Charlie's telling the truth, then so's Bob and so's Alice. Right, so if any of A, B, C are telling the truth, then all of them are. Then all of A, B, C are telling the truth. So, therefore, none of them are. None of A, B, C telling truth. Therefore, Diane, D, is telling the truth. Okay, so that's got us in the mood. Part 2 then, they now make these statements. So we've got 2 of the 4 of them are telling the truth. So Alice says that Bob is lying. Bob says that Charlie is lying. Charlie's fixated on beer, and Diane says something that's obviously true. So that's a starter then. So we got D is obviously true. So we've got one of these ones is telling the truth. So Alice is saying that Bob is lying, and Bob is saying that Charlie is lying. Well, one of those must be the case. So, yeah, so one of A, B, C telling the truth. Therefore, one of A and B telling the truth, because at least one of B and C must be lying. At least one of B and C is lying. So we've got one of those. So we know that Charlie is lying. Therefore, C is lying. Therefore, B is telling the truth. So that leaves us then with D and B. So D and B. Right, part 3. Now joined by Egbert. They each make the following statements. Okay, now 3 of the 5 are telling the truth. So Alice says that she likes wine. Bob says that Charlie is lying. Charlie says that Alice is lying. Diane says that Alice likes beer. Egbert says that Alice likes beer. So we have to have 3 of them are telling the truth. So, well, if we've got 2 of them saying the same thing, so that's got to be, because I mean, if D and E were lying, then the other 3 would have to be telling the truth, but then Charlie would be telling the truth about Alice lying. So that seems to be a good start, doesn't it? So if D and E lying, then A, B, C true, but C says A is lying. So that's our contradiction there. So we've got, therefore, D and E are telling the truth. And then we have to have one of those other 3 is telling the truth. So we could have that Charlie is saying that Alice is lying. I mean, Alice saying she doesn't like wine doesn't really help us at all, does it? I mean, we don't really know if Alice likes wine or not. I mean, if she was telling the truth, then Charlie would be lying, and then Bob would be telling the truth. So that fits then. So as in it doesn't fit, it's a contradiction. If A true, then we've got C is a lie and B true. So that's no good. So we can't have A is true. If we've got if C is true, then we've got that if C, maybe let's not go for this. Let's go for if B is true. So if B is true, then C is a lie, in which case A is true. So that doesn't work. So we must have that if C is true, then we've got that A is a lie, and we've got that B is a lie. So that fits. So we've got C, D, and E are the 3 of the 5 people telling the truth. Right, okay, so that was quite a nice little question. I like those sort of questions. They're quite good fun. That was maybe one of the easier ones of that type, but they're still nice to do. I like those. Let's look at question 7, because that was quite quick doing that one. Suppose you have an unlimited supply of black and white pebbles. There are 4 ways in which you can put 2 of them in a row. Okay, yeah. Write down the 8 ways you can put 3 pebbles in a row. Right. So black, black, black. Opposite is white, white, white. Black, black, white. White, white, black. Black, white, black. White, black, white. And then what could I have there? I haven't done a white, black, black for a black, white, white. Right, so that's 8 different ones, isn't it? They're all opposites of each other. Okay. In how many different ways can you put n pebbles in a row? Well, that's going to be 2 to the n, because you've got 2 options for each one of them. Suppose now you are not allowed to put black pebbles next to each other. There are now only 3 ways of putting 2 pebbles in a row, because BB is forbidden. Yes. Write down the 5 ways that are still allowed for 3 pebbles. Right, so we can't have 2 blacks in a row. So we're going to get all the ones down the bottom plus that one. So we'll have that one, that one, that one, that one, and that one. Excellent. Now let R subscript capital N be the number of possible arrangements of n pebbles in a row, still under the restriction that black pebbles may not be next to each other. So R2 is 3, R3 is 5. Okay. Show that for n is greater than or equal to 4, we have Rn is Rn minus 1 plus Rn minus 2. Hint, consider separately the case where the last pebble is white and the case where it is black. Right. So, well, let's follow their instructions then. So if last pebble is white, then, well, we've got no restriction on the one next to it. That must be what they're getting at, because that's the only reason we'd look at the last pebble. There's no restriction on next to last pebble. So we have, well, we'll have an Rn minus 1 is going to be the option that we have for that, isn't it? So we're going to have Rn minus 1 options, each with a white on the end. Right. If last pebble is black, then we've got that the next to last must be white. So we're going to have, yeah, so we'll have no restriction on the pebble before that. So Rn minus 2 options, each with WB on the end. Okay, therefore Rn equals Rn minus 1 plus Rn minus 2. Okay, so they've done that sort of question before, where you look at things that happen at the end. That's what made it a little bit easier to piece that together. It's not the first time I've seen that type of question. It comes up in MAT papers sort of semi-regularly, where you're looking at like the first or the last in the sequence and seeing how it fits with those restrictions. Right, finally, suppose that we impose the further restriction that the first pebble and the last pebble cannot both be black. Let Wn be the number of such arrangements for n pebbles. For example, W3 equals 4, since we now can't have BWB. Right, for n is greater than or equal to 5, write down a formula for, okay, Wn in terms of Ri and explain why it's correct. Okay, right, so we've got various options then here, haven't we? So we can't have the first and the last pebbles can't be black, right? So, right, this is going to be interesting though. They can't both be black. Well, if we have, I wonder if I need a new sheet for this actually, because this might require a bit of writing out. So let's start this up again. Right, so let's start with the easier one of having W's in then. So if it starts with a W, then what can we do? If it starts with a W, well, we don't have to worry then about the first and the last both being black. So we can ignore that bit. Then not possible for first and last to both be black. Therefore, we've got, well, it's going to be Rn minus 1 options with W at the start. In fact, I mean, we could have done it with the same by saying if there was a W at the finish, we would have got exactly the same thing. So that's if we've got a W. If it starts, again, we could say ends, but it doesn't really matter which way around we do it. If it starts with black, then the last must be white. Okay. And, well, also the second has got to be white as well. Second must be white. So we're saying that we've got B, W, something, and ends in W. So therefore, we're going to have Rn minus 3 options with BW at the start, well, added to, I should say, added to the start, and W added to the end. I should say the same here, I suppose, options with W added to the start. Okay, so we've then got, therefore, Wn is going to be Rn minus 1 plus Rn minus 3. Cool. So that's done that one. So that's wrapped up the specimen papers as well, which has sort of got me up to date from, well, 2007 plus the specimens all the way up to, well, at least the 2 questions that they released from the 2024 paper. We'll see if anything else comes out in future.